Alright, we have identifying rotational symmetry, the other type of symmetry. So we had line symmetry where you fold, rotational symmetry where you turn. Alright, a figure has rotational symmetry if it maps onto itself while you're rotating it. An angle of rotational symmetry which is greater than 0 but less than 180 is the smallest angle of rotation that maps a figure onto itself, and we're just looking for the smallest rotation that does it. For instance, this guy right here, if you turn it 72 degrees, it turns back into what it was originally. And consequently, if you have a symmetrical figure like this, and you count how many points it has, 1, 2, 3, 4, 5, and you take a full rotation and divide by how many equal points it has around the edge, or how many figures that are similar to each other, you will get that smallest angle. Alright, we'll talk about that later though. Alright, so if you look at this, how many times does this triangle map onto itself? When does it make this figure? And we're going to do this with patty paper in class, but for right now, if you just look at it, we can see that it maps on at 60 degrees, right? And it maps on at, so it's not 60, that's 120 actually. So twice, this figure right here will map onto itself 2 times. And how many times does a triangle coincide with itself? 2. Alright. How many degrees? Well, again, there's 3 equal points, so 360 divided by 3 is going to give me 120 degrees. And then again at 240 degrees, and it's a full circle, so everything has this 360 degrees right here. So how many degrees did we have to rotate the figure? 120 degrees. What are all the angles of rotation? So it's 120 degrees, 240 degrees. I'm going to go ahead and throw 360 out here, but you can't really count 360. Alright. So this one, determine whether the figure has rotational symmetry. This one does. It's a square, and there's 4 sides, so if I go 360 divided by 4, it's every 90 degrees. So we'd have 90 degrees, right? We'd have 90 plus 90, 180 degrees. We'd have 180 plus 90, 270 degrees. So we would have 3 times, and then it would turn a full circle and, of course, map onto itself. This guy right here, this triangle in the middle, I can't see it ever looking like that again until, I'm just looking at this triangle saying, hey, is it ever going to take that shape again with a small angle on top? Not until we get all the way around. So we're going to say no. We cannot list 360 because everything has 360. This guy right here, as I rotate it, it looks the same right there at 180 degrees. So we would say 180 degrees. What figure maps onto itself by any angle of rotation? Alright, that's what this next guy says. Uh-oh. I'm going to give you another hint because of the tool I'm using. But if you look, anytime you map I'll see if I can, I'm going to move this down just a little bit, see if that works out. Anytime you turn a circle, in any position at all, if I turn a circle around this point, it's going to look the same, right? So, just like line symmetry, a circle has any point, 360 degrees, every portion of that, 3.11111 angle of symmetry, or rotational symmetry. Now we got one more discussion down here. I've gone ahead and drawn it. If you want to pause it, that's cool. I did 2 lines. I had line L and line M, and I made them intersect at 60 degrees. And the question is, if I rotate this guy 180 degrees, all right, or well, no, if I rotate it 60 degrees, will it look the same? Well, it's pretty easy to rotate 60 degrees. It's right there. That's 60 degrees, and there's no way it looks like this when I rotate 60 degrees. Alright, this one's a straight line with a 60-degree angle at the top and bottom. This one is a straight line with a 120-degree angle here and a 120-degree angle here. So it doesn't look the same. So we would say no. You would need to rotate, and I'll show you this one works, 180 degrees. So watch. If I take this and I rotate it 180 degrees, so there's 180 degrees. It once again has a 60-degree angle here and here, and it works out. And that's page 2. Alright, I'm going to pause this, and we will talk to you guys tomorrow.